Okay, we are back. This is Techmath2, and we're looking at chapter 9 in the red book, Identities, Inverse Notations, and Equations. So we're back to right triangle trigonometry. That is page 393. So 9.1, we're looking at the inverse. Take a look at number 1. They give you a right triangle, and we've got A, B, C, and theta right there in that corner. And so they want to know sine, what's the sine of theta, what's the cosine of theta, and what's the tangent of theta. And then they also want the cosecant of theta, the secant of theta, and the cotangent of theta. All right? And so, if there's that mnemonic device, SOHCAHTOA, that is a way to memorize these three functions. So sine is opposite over hypotenuse. So when you look at it, here's theta, opposite is right here, and hypotenuse is always the side opposite the 90-degree angle. So A over C. Cosine is adjacent over hypotenuse. So if this is opposite and that's hypotenuse, then this other one is adjacent. So that's B over C. Tangent is opposite over adjacent, opposite over adjacent, A over B. So now, it's kind of obvious, tangent, and then its inverse is cotangent. So that is B over A, the reciprocal of this. These are not as easy. The way that I memorized these were, like, I'm not a great speller. You probably, my penmanship is also lacking, as you can see. But cosine is like secant spelled backwards if you're a bad speller. You know, there's an E instead of an O, but, you know. And so that's C over B. And then cosecant is the one that's left. If you have cotangent, secant, you know, and then cosecant is the inverse of sine. So C over A. All right. So those are the 6 trigonometric functions. Those are called the 6 trigonometric functions. That's quite the mouthful. All right, so let's take a look at number 6 next. So we got, they want us to find the cotangent of B, they want us to find the cosecant of B, and they want us to find the secant of B, angle B. All right, so they gave us a picture. Looks something like this. There's angle B, and this is side T and side M and side B. And so until you get the hang of it, what I suggest is you do sine, cosine, and tangent. Sine, cosine, and tangent. B, B, B. So opposite the 90, this is the hypotenuse. So if this is my angle, sine is opposite over hypotenuse, B over T. Cosine is adjacent over hypotenuse, M over T. And tangent would be opposite over adjacent, B over M. Okay? Now, I know they didn't ask for sine, cosine, or tangent, but now when you have these written down, you just have to go, okay, well, cotangent, that's this one. The reciprocal, so M over B. Cosecant, that's the one that goes with sine. So that's T over B. And secant is sort of like cosine spelled backwards. That's T over M. All right. Lovely, lovely. Let's do one more. Oh, on our calculators, Let's look at 11. They want us to find the secant of 77 degrees. They want us to find the cosecant, 230 degrees. And they want us to find the cotangent of negative 112 degrees. Okay. So I know they're all in there on the catalog. I think there's another way to get to them though. That ain't it. So it is not second sine. That's arc sine, remember, and arc cosine and arc tangent. So that is not how you find those. I want to say there's a way to find them somewhere. I know you can always default and just go to the catalog and go down until you find it. So if you hit second and then 0, second and then the 0 is catalog, see? And that'll bring up all of the list of all of them, and you can just keep clicking down until you get to cotangent. Oh, maybe not. Oh, maybe they don't have it in here. Seeing cotangent, I'm seeing cosine. I think of the newer ones, they might have them. 83 not. So how do I find these? Well, let's go. To find the secant, that's cosine. So you do cosine of 77 degrees, and that gives you that. And then just take that to the point, or to the negative 1 power. That's the reciprocal. And then hit enter. Or you could do it like this. If you hate that, you can go 1 divided by the cosine of 77 degrees. And that's the same thing. That's probably easier to think of it that way. 1 divided by the cosine. So that's 4.44. Cosecant, that's sine. So that would be 1 divided by the sine of 230 degrees. And then hit enter. Negative 1.305, and cotangent, that would be 1 divided by the tangent, no second, just the tangent of negative 112, and that would be 0.404. So we've got all 3 of them. .4454. We've got negative 1.3054, and we've got 0.4040. All right. So you just do 1 over its inverse function. All right. So the ratios. Let's look at ratios. So that's number 11 on 9.2. The ratios are how do tangent. You might have wondered, where tangent came from. Sine is this, confined sinusoid that goes up as high as +1 and down as low as -1 and just keeps going back up and down. And cosine is really the same thing, shifted 90 degrees. And tangent is this crazy curve that goes up forever and down forever and have all these asymptotes. Well, the reason that tangent works in with right triangle trig, if you take a look at number 13, it's the tangent of theta is actually equal to the sine of theta divided by the cosine of theta. And then the cotangent of theta would be the inverse of that, the cosine divided by the sine. And that's always true. Oh, they just had or the other way, but the cotangent is going the other way around. All right. And so they showed a proof of that, the sine and the cosine, if you look on the next page. All right, let's look at 14. That's also proof positive of this. They have it already worked out. They took the tangent of 47 degrees on the calculator. It's 1.07. Now, if you do the sine of 47 degrees divided by the cosine of 47 degrees, and then hit enter, you will get exactly the same thing. All right, make sure you do that end parenthesis. If I'm keying it in, sine parenthesis 47 end parenthesis divided by cosine 47, and then that one doesn't matter if you put the end parenthesis in or not. You can just hit enter. Okay. Next one they want us to check is the sine of 212 degrees divided by the cosine of 212 degrees. And that works out to be the same. That's 0.6248693. And then they want the sine of negative 68 degrees divided by the cosine of negative 68 degrees. And again, the exact same as the tangent of negative 68 degrees. Negative 2.47. ... Okay. Lovely, lovely. Then let's go to 9.3. We're looking at, the Pythagorean identity. If you take sine squared and add it to cosine squared, that will always, always, always equal 1. True story. So if you take a look at number 20, 9.3, that is, not number 20, number 24, sorry, number 24. That shows sine squared theta plus cosine squared theta equals 1. Now, what does that mean? What kind of shorthand is that? That means if you took the sine of theta and put the whole thing in parentheses and then took it times itself. That's the shorthand. They put the squared on the sine instead of having the whole thing in parentheses like this. But that's what it actually means. So sine theta times sine theta plus cosine theta times cosine theta will always equal 1. And if you look at why that is, it's, you can take a look at, they have the unit circle where it's kind of over 1, so it's x squared plus y squared is equal to 1. So if you weren't on the unit circle, if that was 5, that 5 squared, 25, would end up dividing out of both sides of the equation, and you end up with x squared plus y squared equals 1. All right. So that's Pythagorean theorem no matter what, when you have a right triangle. Now there are 2 derivations off of this. And let me show you. You could just memorize them, but there's a way I got around memorizing them. Let me show you. So the answer is tangent squared theta plus 1 equals secant squared theta. And you might say, oh, that doesn't even look anything like that. It's actually derived from this. If you take this and write sine squared theta plus cosine squared theta equals 1, but then you divide each term, so you divide both sides by cosine squared. Look at what happens. Cosine squared, and cosine squared. Well, cosine squared divided by cosine squared is 1. 1 over cosine squared is secant squared theta. That's right. They're reciprocals of one another. And sine over cosine is tangent. So it's sine squared over cosine squared is tangent squared theta. So tangent squared theta plus 1 is equal to secant squared. Tangent squared theta plus 1 is equal to secant squared. So all we did was we took this and divided every term by cosine squared and simplified. All right? So that was a way I got around actually memorizing it by you just divide it, and then there's the other thing. And then there's another derivation. You can probably guess what that's going to be on 28. We've got 1 plus cotangent squared theta equals cosecant squared theta. So instead of remembering this, it is also derived from that. You start with sine squared theta plus cosine squared theta. equals 1. And now we're going to divide everything by sine squared. So this divided by sine squared, this divided by sine squared, this divided by sine squared. Essentially, I divided both sides by the same thing. I just distributed it on the left side there. So this divided by that is 1. Sine squared divided by sine squared is 1. Cosine over sine is the cotangent. So since it's squared, that's cotangent squared theta. And 1 over sine is cosecant squared. And there we have the exact same identity. So all of them, the Pythagorean identity, these are just two different derivations. We derived them from the original. All right? Lovely, lovely. We will use those when we're doing like proofs and things in 9.6. So let's take a look at 9.4. So in 9.4, number 32, they want me to prove that sine theta cosecant theta is equal to 1. So to do a proof, you usually pick one side, the more complex side, and make it look like the easier side. Never move it from side to side, never divide out on both sides, because then you run into domain restrictions and stuff. So if I wanted to prove this, well, first of all, you could just say, well, sine times cosecant, those are reciprocals. When you take a reciprocal times a reciprocal, it's always 1. But usually you have to pretend when you're doing a proof, like the person on the other end of the proof doesn't get anything mathematically. So you go and say, well, this is equal to 1 over cosecant theta. That would be one way to do it. You could also do it and leave sine alone. Let's leave sine alone and say this is 1 over sine theta. That's what cosecant is. It is the reciprocal. Remember, that's how we found it on the calculator. Then when you're multiplying fractions, you do numerator times numerator, denominator times denominator, and 1 equals 1. And that's like a proof. What you did is you started with this and you wanted to prove that, you know, it was equal to that. So we made the left side look like the right side. All right? Okay. I don't like how they did it. They did it, that's really poor form on number 32, because they multiplied both sides by 1 over sine theta, had it cancel, and then said cosecant's equal to 1 over sine. You shouldn't really work both sides of an equation when you're proving an identity, because you have to worry when you divide both sides by something that you might be messing with the domain. You might create a domain restriction. Like, for example, we couldn't have sine theta equal to 0 ever, because I'm dividing by sine. So it's better to pick one side and just work on that one side and not do both sides like that. So that's actually considered bad form. Let's look at 33. What do they want here? Solve. So they want us to solve this. That's different. That is not a proof. When we're solving, we can do just like how we solve equations. So cosine theta secant theta equals 1. They want me to solve for cosine theta on that. All right. So then, this is kind of weird, but we divide both sides by secant theta, and then we just have cosine theta equals 1 over secant theta, which is actually cosine theta. You know, if I simplified that all the way down, that would be cosine theta. I don't think they want us to simplify it. They just wanted us to get cosine theta by itself. And then it said solve for secant theta. Well, that's going to be the same thing. Cosine theta, secant theta equals 1. If they want me to solve for that, I divide both sides by cosine theta. And then secant theta would equal 1 over cosine theta. which is secant theta, but they don't want you to make that last substitution to prove it. They just wanted this all by itself, I guess. All right. And then what about, yeah, it's really the same on the next one. So let's go 9.5, the 8 basic identities. So let's write out our 8 basic identities, okay? For 9.5. We have the reciprocal identities. We have, we're looking at number 36 here. Ratio identities and Pythagorean identities. So reciprocal identities, that's just sine theta times cosecant theta is equal to 1. Cosine theta times secant theta is equal to 1. Tangent theta times cotangent theta is equal to 1. So just what you would think. If you take reciprocals and multiply them, you'll always get 1. The ratio one, that's tangent of theta is equal to sine over cosine. Sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta, the reciprocal of that, right? And then the Pythagoreans, we just looked at those. Sine squared theta plus cosine squared theta equals 1. And then if I divide everything by cosine, that is sine divided by cosine, that's tangent squared theta plus 1 is equal to secant squared theta. And then if I divide everything by sine, I get 1 plus cotangent squared theta equals cosecant squared theta. All right? So those are all the identities. Then let's see, they just want us to fill in the missing blank for 38. So sine squared theta plus blank is equal to 1, and blank plus 1 is equal to secant squared theta, and 1 plus cotangent squared theta is equal to blank. So all three of those are just the Pythagoreans, right? So sine squared plus cosine squared is equal to 1. And tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So we just had to finish those little pieces for 38. And let's look at 42. What is the sine equal to? Sine theta is equal to 1 over what? Oh wait, they want everything, huh? Okay. So sine theta is equal to 1 over cosecant, for sure. By rearranging the basic identities, write 4 expressions. All right, so we got that. So then I guess we'd have to rewrite this one, like cross multiply and solve. So sine theta would equal tangent times cosine. Like, you know, just by making that identity and cross multiplying and solving. If we cross multiplied and solve this one, we would have sine theta, it would be sine cotangent would equal cosine, and then we divide by cotangent, so I guess that would be cosine theta over cotangent theta. And I don't think they want the square root. Oh, no, they want the square root. Okay, so let's solve that one. So sine theta is equal to 1 minus cosine squared, and then you got to take the square root of that to get rid of the squared part, right? So I subtracted that and then took the square root. Yeesh. So I think that's all of them. 1 over cosecant, cosine tangent, cosine divided by cotangent, and 1 minus cosine. Okay. So that is it. 9.1 to 9.5.